Good evening. My name is Tom Reardon, math teacher from Ohio. This is utilizing TI graphing calculators in core math classes, basic algebra through Precalculus and Trig. This is for community college and university instructors and/or professors. The moderator for this evening is Michelle Grooms. She's an education technology consultant for Texas Instruments, and for the last 20 years she is working in supporting education technology. The rest of her bio is right there, and you can pause the video. Our first panelist is Veronica Carlson. She is from Phoenix, Arizona, and she has taught high school mathematics for 35 years and also is an adjunct mathematics instructor at Glendale Community College. The rest of her bio is here. And again, my name is Tom Reardon. Taught mathematics at Fitch High School for 35 years and 40 years adjunct at Youngstown State University. Since 2009, I've been a full-time senior math advisor for Texas Instruments, and the rest of my bio is there as well. So the agenda, see how math instructors have been using TI technologies in their classrooms for over 30 years. And when we say that, we mean at the community college and university instructors. Get creative ideas on how to use these calculators. And our main thing is to assist in students' conceptual understanding and retention. That's the goal there. Also discover how to use either the TI-Nspire Smart View emulator software or the TI-Nspire teacher software to use as a demonstration tool in your teaching. And by attending this webinar, you get both those softwares. Contact Michelle Grooms if you are just watching this video now. Expected outcomes. I can see the value of using these graphing technologies. Find several ready-to-use activities, and also how to get additional information. Use calculators effectively and appropriately. Here's a partial list of the college professors and/or instructors that use TI-Nspire or TI-84 or both in their affiliations. Take a few seconds to see if you recognize anybody in that group, or at least the affiliations. And the other half of that list, again, these are teachers, instructors who've been using this at the college or community college level for many, many years. If you have a question, please do that in the chat. All materials and links are available now at this website right here, bit.ly/university and then capital TI. It is case sensitive. Since this is being done after we did the May 12th one, you can get information on both of these. Okay, click here to get Veronica's slides, my slides, and other information. Some essential links here. The May 12th, which was more on calculus, linear algebra, and statistics. You're welcome to get that. This is the contact information for either Michelle or Parisa. So this is the beginning of Veronica's slides. We started the recording a little bit late, so I'm just covering that for her, and then we're going to resume right into hers. So these are the two calculators, the TI-84 Plus CE, a color graphing calculator, and the TI-Nspire CX or CX2, also a color calculator. And Veronica's going to tell you about getting the current calculator operating system, OS, and also having the current operating system for CE. She's also going to mention something called TI Connect CE. So we'll now go ahead and resume in progress with Veronica's presentation.
And so here we're currently running 5.4.0 and extra numbers there. It takes you a link to education.ti.com, or we'll give you a website link that you can go to go update your software if you need to, if you already have the new Smart View, but you need to update it. And then there's TI Connect, and that's how you can send files back and forth from your calculator to your emulator. And so you need to have TI Connect, and that's the updated version for TI Connect. This session is not dealing with that or showing that at this time, but you need to have TI Connect as well. So let me go back over here. So one thing that I think is really cool and new with the CE is that there are some hidden menus, and I'd like to demonstrate where you can get those hidden menus. And it makes, I'm going to say, the math look like math. You know, just like we as mathematics instructor like to see. Sometimes it's referred to as pretty print or pretty math, and so we can see those things with these function keys. So alpha function 1, but I'll say the y equals key. And there I can see and get actually a template to enter in a fraction to make it look exactly like a fraction. And so that's something that's really helpful. If I go alpha window or F2, there now I get, look at that, a wonderful absolute value symbol. I get the summation, derivatives, log base, higher roots, and there's quickly my probability and combination, my factorial. So another thing I can do is I can just move these arrow keys. If I kind of forgot, gee, which one is it? I know it's these, I think they refer to them as soft keys up here. I can just move this arrow over, and now I can go create a matrix super fast. I think Tom's going to demonstrate that. And then here I have my y bars, where I can go find these y variables and go paste it in very fast. Again, instead of going, I can still use the old way into going into vars. I remember long ago when I started learning, we always talked about going to the vars after school. So, okay, so that's something that I think is helpful, and maybe you weren't aware of that. The other thing is that I can also, of course, we can enter in the quadratic formula, and I can just go up and copy. And let's go see what I have over here in my emulator. But I can also get two answers at once if I enter that part as a list. And so I don't know if that's something that you're familiar with. So let me go in here to load my emulator state, and I want to have quadratic formula two ways. And so here I have my quadratic formula, and then just to make sure that everyone's aware that you can just arrow up, and if there's something that I want to copy, I just push enter, and voila, I'm able to copy that very quickly. Just to save time, just because we started maybe a smidge late, I'm going to just load this one so you can see that I can change this. Instead of having my +1 and my -1, I can load it as a list. And I think that was pretty cool. And I don't know if that's something new for you, but it can be helpful and a little bit of a time saver, and helping to reinforce that we have two values here. We're looking for, we're expecting to have two values. Maybe we have them, maybe we don't, but that's part of evaluating a quadratic function. Let me go back to my notes here. And another thing that's awesome, very valuable, is when I do my graphing, I can split the screen and see a table at the same time, which is very powerful. And so I'm going to go here, and I'm going to go load my emulator, and I'm loading pre-done states. And I have to tell you that Tom's the gentleman that showed me how to do that. And so here I have my two functions that I've entered, and I can go and see them, and that looks great. I can see that there's a couple of intersection points. But what I want to do is I want to go into mode. And when I'm in mode, you can see here that I have graph table. And so I have to arrow down, and I'm here at full screen, horizontal screen. I can show you what that looks like. It's not going to be that helpful. It's kind of hard to see, but that's the horizontal screen, and I can have things underneath here, the keystrokes. So let's go back to my mode, and then I want to go to the graph table. And I'm going to push enter. And so you have to push enter, make sure you make it stick. I've selected it. I can't just arrow on top. I have to push enter, graph, and look at that. Now I want to go to my table. So second table, I'm in my table. My table is what is active right now. And I can arrow into my table. And you can see here what's happening is I'm showing my X value and there's my Y value. So again, that is something that's very helpful in making connections with students as far as here's a 0, what's happening as I continue. Look, I have another 0, I have 2 zeros. So you can have lots of different discussion and showing that at the same time, as opposed to if I am in trace, I can still do my old-fashioned trace, but it's just kind of not as pretty looking. I can still switch and I can go to my other intersection point, but I sure have to say that I really like going back to table, and that was just second table, and it takes me back to that really nice looking table there. Okay, let's see what else I have there. And there's the graph table. Graphing a piecewise function. That's something I don't know if you're familiar with. And so I'm going to demonstrate that for you. And so let me go back here. And I'm going to go actions, load emulator state, and piecewise function. All right, so here's my piecewise function, and I'll just go down to demonstrate where I got that template. And so I'm in my graph, and I want to show that. And so I'm going to go to math, and I have more here, and so I can go all the way down. But I also want to make sure that you understand, or a little shorty cut. I love all the shorty cuts. If I just arrow up, that takes me pretty fast to piecewise, And here I can say how many pieces I want, and all right, and there I have it, which I have already entered. And again, I could go and I can put in a graph table if I want to. And so another thing that I wanted to show you is that I can also enter in a piecewise function in my equation, and I can save it. And so, or on my calculator page, and I can save it and I can store it. So I'm going to go alpha store, and then I'm going to go into my math, and I'm going to go and get that piecewise template, just like that. And just to make it a little bit quicker, I'm just going to go 2 pieces right there. And so the first one that I'm going to have is I'm going to have just an X, and I'm going to arrow over, and I'm going to say that I want X and I go into test, and I want it to be less than 1. And then let's make this one a quadratic, squared. And I want this one to be X, second test. And I want it to be greater than or equal, a concept that's really difficult for students to understand. And I'm going to go and close my quotes. So alpha quotes. And then I'm going to go and store this. And so I'm going to store, which is right here, store. Oh, whoops, I'm sorry, I have to be out. Better fix my quotes. All right, oops. Second test, number 4, 1, and then I want to be outside my quotes. There we go. And I'm going to store it. And this time I'm going to use those shortcuts. shortcut keys. So alpha trace, and I'm going to store it in, I'll give myself some room there, Y3. And I have to push enter, and it says it's done. I'm going to go over here to Y3. I see it there. Notice that this graph is turned on, and I don't want to see both at the same time. So I'm going to go and I'm going to turn that off. And I have this one that I'm going to graph. I'm going to graph it, and there you go. I'm going to go back here, and I just want to make sure that you know that I can push enter here and that I can change my color. And we're going to change it to that pretty magenta. And I can change this to, I call it ball and chain. I've called it that for a long time. And I'm going to go ahead and graph, and there it goes. So this is another example of, you could use this when you're discussing domain and range, helping students to understand what all those X values are. And so it has lots of capability. I can also show all of my screens here at once. You want it to be dynamic, but you do have to go and you have to refresh it. So let me go back to my smart notebook, and we did that. And so now I'm going to move over to my TI-Nspire CX emulator and just demonstrate a few things here. Again, you have teacher premium software that you'll be given free. And one thing you might be thinking, well, gee, that's great, but I don't have these handhelds for my students to use, and I'm not right now going to make them purchase it. So the thing that you could do as an instructor is use this as a demonstration tool, and there's still a lot of power in that. And sometimes in the classroom, I prefer that because I'm in control. You know, I'm showing what I want students to see, and that's a nice another great tool. This one also has calculator operating systems that you can check. So both have operating systems. I can go into my Nspire, and I can go here to help, and I can go to about, and here's where I have my information about my version right here that you can check easily. All right, and so again, checking for OSs, you always want to be up to date. And one thing that's very unique with this TI-Nspire CX2 is that you can combine different applications together, and you can have it all in one document. And I think there's a lot of power in that. But just to get you started, I wanted to show you that there are several different application modes that you can use, and the menus for these are all different. Kind of like when you go to a different restaurant, Italian or Mexican food or Asian, you're going to have different type of menus that you're going to select your meals. Well, here we have different menus that we're going to select our functionality and what we can do in the various applications. I can do that. I'm going to add a new page, and here's all my applications that I can use. One thing that also is very powerful is we talk about real world math, and we want to connect it, and we want our students to actually see, sometimes our data is very contrived, and here we can actually go and get data. We can go and have very easily a temperature probe. We can add a motion match, and it's really good for rate of change. So that's something that having this Veneer Data Quest app is very helpful, and makes it very easy to use in the classroom. And again, something that you as an instructor can just demonstrate to your students for the to see and to collect that data. And then here we of course can split the screen here, and I just have to give a shout out to TI-Nspire CX2. That aren't these lovely? These are wonderful graphs. Oftentimes too, I use these graphs and I put them into my documents or into my assessments, and I can do lots of things. I can hide things on them. That's just another session, but we can there's so many different things that we can do. And so I'm going to go ahead and add a graphs page, and I'm going to enter in my graphs. And so I'm going to have, I of course have my nice templates, and I have 1/2 x squared and minus 2. And I can move these around. I can even move this if I wanted to. I'm going to just push tab. That's a shortcut way to get another function line. And I'm going to go in here and I'm going to get a 1/4. And I have x plus 3. Unlike the TI 84 plus CE, this does not have a variable key. So the X, Y, and Z, though, are colored different, and sometimes that's helpful, and you're going to see that's a little bit more useful. And so here I have my two functions. It comes up just like with the CX, with the 84 CE, it changes the color. Each function changes color, and that's always very helpful. Again, a visual. And here I can just, I'll show you a shortcut, Control T for table. I can go and get that table lickety split. I can move in my table. You can see that this is kind of outlined right here, and so that's the active screen right now. I can go and look to see what's happening here. I can also move the table over a little bit, so I still have my x value, and now I'm looking at my my second function, and I'm looking at those values. So again, something that's certainly very valuable in helping students to better understand what does it mean when we're looking for intersection points. What does it mean when we're looking for zeros? And you can actually see that there. I can go Control T to take that table off, but I can also go and insert tables and things like that from my menu as well. Let's see what else I had. I don't know, Tom, how am I doing? I don't want to be a time hog. I'll just show you this one. We can also have piecewise functions. This is a picture that I had taken in Germany, and I'm quickly looking for my picture, and I'm not seeing it very fast. And here it is. There we go. To the next slide anyway. There we go. So here was, I'm always looking for pictures. So here's a demonstration, or I'm showing you that you can insert a picture into a file. You can do it with a TI-84 CE, but I have to say it's so much brighter and clearer in the TI-Nspire. And so when I saw this, I just said it just is screaming to graph me as a piecewise. And so here I can graph it as two separate graphs, and you can see that with the color. But what a wonderful demonstration to show that I can have a piecewise function. And something that is nice is if I use something called Pathplot. So I can go to Menu, Trace, it's a tracing function, Pathplot, and this is a function, and I can actually play that. I can see kind of a little preview what's happening here. I can see here's the points, showing it was undefined. I can pause it, I can play it, I can make it go as well. And this is the area right here where students just really have a difficult time understanding why is this a function, and with vertical line tests. So again, another way that I can demonstrate, I can have a visual in the classroom to help put meaning behind a piecewise function. I think that, oh, and a couple of files, just very briefly. You can go to education.ti.com, and Tom will have that link for you. I can go to activities and math inspired. I mean, I know at the college level there is higher level coursework, but some of these lower, I taught a lower level algebra class, and when I come in here and I go and I can find lots of different pre-made activities that are ready to go. And one that I want to point out to you is exploring domain and range. And domain and range, again, is such an abstract concept, and it just really helps. I'll show a different one that here it's actually graphing. And look at that use of color and helping students to understand the difference, and again, as a visual. And then, so you can see. And then the one thing that's really great is that we do have a different type of function here at the end. And I think there's also, yeah, this J one with an open dot. So, all right, I am going to pass the baton back to you, Tom, and I am going to stop sharing. And I feel like I was just racing.
So yeah, unfortunately we started late, and Veronica, you had some good things to share with them. I wish you could have shown them that domain and range. That's one of my all-time favorites.
Yes, very powerful.
Okay, so let me see if I can share my screen. And so here is my my start. So welcome again, everybody. And again, my name's Tom Reardon, and I was going to share with you some things on the 84 and then also back them up with the Inspire. So one of the things that I'm going to share with you is several different ways of evaluating an expression. And someone asked for the domain and range. So yes, we'll show you at the end where to get that file. So evaluating expression. So let me go ahead and bring up my TI-84, okay? And let's say I want to evaluate this expression at these three values. So let me go ahead and share that. So I'm going to go to y equals, and oh, I should probably turn on my video. That's what I'm being asked to do, so that's a good idea. Um, huh, not letting me. I'm going to stop sharing just for a minute, see if I can pull it up there. Yeah, now I can. There we go. So thank you, Michelle, for that.
I got my video on too.
So I want to evaluate this several places. So as Veronica said, I can get a nice fraction template there and then type in x squared minus 1 in the numerator and then 3x plus 5 in the denominator. And I have this in Y1. I'm going to pull this screenshot off so that you can see it more easily. And this is one of my most favorite features of TI Smart View is you can just use your mouse and drag and drop the screenshot into Word, Smart Notebook, PowerPoint, whatever, resize it, whatever. And I want to evaluate at those places. So what I'm going to do is I'm going to go ahead and graph this. Let me make sure I like my format. Yes, I'll graph this. You can see it is a rational function. And I want to evaluate it at 3, so I'm going to press trace. And if I try to move along, you can see my values aren't going to be very close to 3. So I can just type in 3, press enter, and there's my value at 3, 4/7, a nice fraction. I can also type in 9 and see what the value is, and even go back to -5 and see what the value is. So that's one way, is by graphing and tracing. Another one is using the table, like Veronica said before. I'm going to go ahead and set my table first so that it starts at, say, 0 and has a delta table of 1. And so I like to set my table before I'm going to use it. And now I can go second graph, and I can go through the table, and I can see that at 3, what the value is. I can go down to 9 and see what the value is. And I can go back up to -5 and see what the value is there. Table ask is one of the features that I really like, but not many people seem to know about it. So again, I'll go back to the table set. It doesn't matter what it is, but my independent, if I make that ask, meaning ask the calculator what value it is. Now, when I go to table, nothing's there because it's waiting for me to ask. So I'll say I want to know when it's x is 3, when x is 9, when x is -5. And so this is a nice way to use that. I can type in 100. I don't have to scroll. That's the idea there. And graph table, again, one of my favorite things, and that's what Veronica showed you. I can change the mode again down to graph table from full. And this has been a feature for a long time, so this isn't just necessarily the color. And then I also need to set my table so that it is on automatic. And now I will go ahead to second graph, as Veronica said, so that I'm in the table, and then I can go ahead and trace in the table, and you can see the values on the graph. Again, one of my most favorite things to do there. But also I like is just function notation. So let me go back to mode and turn off the mode so it's on a full screen again. And remember that this is in Y1, so I can go off to the home screen and I can bring up the alpha trace where the vars are, as Veronica said, and say Y1 left parentheses 3 close parentheses, and it will actually do it just like f of 3, y1 at 3, and replace the variable with 3. And I could do the same thing with 9 and -5. And so while we're at it, let's talk about composition of functions, since we're talking about that. So if I go back to y1, and if I leave the f functions in y1, I'm going to type the g function in y2, or minus 5x. And now when I go off to the home screen, instead of f of g of 2, I'm going to type in y1 of alpha trace, y2 of 2, double parentheses. And then I want to show that it's not commutative. Okay, function composition is not usually commutative. So alpha trace y2, left parentheses, alpha trace y1 of 2. And we can see that it will also do function composition, which is something which is very helpful. If I had more time, I'd show you how we could actually graph these and graph the composite function. Also another cool way to do that, but I have other things to show you instead. So let me stop and see, is there anything in the chat that I should be aware of?
No
I
new.
don't think so.
Veronica went ahead and linked that domain and range activity.
Perfect.
In
Thank
the chat, so anyone looking for that, that's there. So thanks for Veronica for that.
Absolutely.
All right, so I just want to show you can also do these with TI-Nspire, okay? It's a little bit different. It's graph and trace here on the Nspire at those values. Again, graph and table on the Nspire. Function notation, really two different ways here. You can type things in F1, F2, and so on, but you can also define functions in Nspire. So I can define it and use f of x and g of x, and then type just as you would see in a textbook. So I really like that idea. So if you're an Nspire user, you can also be doing these things.
That's awesome.
Before I go on, I do want to tell you how I like to use a graphing calculator or a graphing utility. I like to do it as a teaching tool and as a learning tool, not just as a computation tool. Discover things, and we're going to see how you can discover patterns, looking for patterns, discover formulas, check answers. I love being able to check answers with terrible looking numbers. Graphical visualization is a big deal to me. Visualize solving equations, solve tougher application problems that are impossible to solve by hand. And then you can also have electronic flashcards that we won't be able to get to, but those are available to help review concepts. All right, another favorite of mine in teaching from basic algebra up through calculus actually is transformation graphing. And the TI-84 has a transformation app. The TI-Nspire has sliders, and I'll illustrate both. So let me start off with this here, okay? Again, using this, and I'm going to go ahead and clear out what I have here. And under apps, the last one, the transform app, okay, looks like this, as you can see. And I'll press enter. And I'll go ahead into y equals. And I like to put my parent function in y. Oh, you'll notice, by the way, that my y1 and y2 have these little widget things next to them. So they're a little bit different, meaning I can do transformations with those. The y3 does not. So in y3, I'm going to type in the parent function, which is x squared. And in y1, I'm going to type in y equals x squared plus some constant, and I'm going to use the variable c for that constant. And now when I graph this, I don't know what C is, so I'll go ahead and graph it. And it looks like C was equal to -3 when I started this. And normally I'd like to have C start at 0. So let me just type in 0. And now I have both of those. You can't even tell the difference between the two of them. And how you increase the values of the parameter is you press the right arrow to increase it. So y equals x squared plus 1 plus 2 plus 3. And left arrow decreases that. You can also change the step, but for right now, I think we'll be fine with just a step of 1 for our purposes. Again, let me pull those off and see that. So I think this is really helpful for students to be able to discover, what the vertical shift looks like. I can go back and also look at what happens if I have a number times that, x squared. So let me use a there. Times x squared. Yeah, the time sign, by the way, is optional. Okay. And by the way, I said this in the chat, both of our presentations, slides are available, and they've been cleaned up a little bit. We kind of ran through it and cleaned it up so that if there are things we didn't get to, you'll still be able to see them. So, and I'll point how to get those at the end. So y equals a times x squared. Let me go ahead and graph that. And it looks like a is 1 to start, which is good. And now again, I increase a and I can see what's happening to the parabola. Or I can decrease a and like to see the opposite there. I can even type in a number like 0.5 and it'll automatically change the value for a, and I can see how that's wider. Okay. And then finally, I can have up to 4 parameters. And so I could actually have like alpha A times the quantity x minus b, the quantity squared, plus c. And I have no idea what a, b, and c are, so I'll just go ahead and graph it. And you can see that a is 1/2, b is 0, c is 2. And again, I can change this. So I'm sitting on a, I can go ahead and just type that as a equals 1. And if I want to get to the other ones, I use the up and down arrows to get the other parameters. So I can go ahead and increase b to say 1, 2, 3, and see how shifting to the right is x minus 2, x minus 3, and so on. And x minus a negative makes you go to the left. So again, you can play with this, and that's what I really like to have my students do, is play with these values here and be able to learn from playing with the mathematics. So again, you can have up to 4 different parameters in this one. Now, as far as seeing this on Nspire, I won't demonstrate it because of the time, but you create a slider, and it's like here I use the V for the vertical shift. Okay, I don't have. By the way, the letters on the TI-84 have to be A, B, C, and D. Right, okay, but on the Nspire you can use any variable here. So you can see I've got y equals x squared, the slider pops up, I can slide it back and forth, or I can change the slider so that it clicks up and down to increase or decrease that, okay. Here is y equals some constant times x squared. Again, 2 different looking sliders, okay. Again, you can also type in your own parameters on Nspire. And then again, you can have up to 4. You might even actually have more than 4. Here I used our good old buddy y equals m times x plus b to show you how you can have actually 2 going on at the same time, and even more so than that. So while we're talking about transformation graphing, TI has a new website that has how you can explore transformation graphing called Families of Functions. Over 250 videos that illustrate how to graph the parent functions and their transformations, and these are just pictures from slides of those. This is the website that I created for you guys that has information not only about today's, but also next week's for the calculus, linear algebra, and statistics. And I'll explain these at the end. This is a quick link to the transformation graphing videos. So you can, if you go here, you can get there, or you can go directly just to that. And the main thing on that is that you can download the quick reference guide. It's like the main thing here, okay? So if you go here, it says download the quick reference guide to all videos and materials for the course. Um, I'll show those in a minute. But what this does is graphs the 13 parent functions, shows how they're graphed as if you've never seen them before. And then it also has a quick like review version of the graph. Each of the 6 transformations, vertical shifts, horizontal shifts, opposites of functions, vertical stretch and shrinks, horizontal compressions and expansions, and F at the opposite of X. These are all free and modular. You only use the videos you need to use. Online course, a review, if you're doing flipped classroom, independent study, just to augment what you're doing in your classroom. And it's independent of any graphing technology you're using. The videos, we're teaching them how to do this by hand. These are our 13 parent functions, and I'll pause there just for a second. Hopefully those have your favorite parent functions, and if it's more, that's okay. The linear also has 6 mini videos on slope, on how to how to calculate slope from a graph, from a table, draw lines with slope, things like that. Sine and cosine are coming soon, and if you would like to get the sine and cosine as they're being developed, email me, and I will get you that. Where do you find this again? I will show you shortly. So again, 13 parent functions, 6 transformations, 250 plus videos. This is essential. If you don't do anything else from what I tell you, please go there, download the quick reference guide, look at it. If this is something you and your students can use, give it to your students, give it to your colleagues, okay? And if it isn't, let me know why it isn't, okay? So here are the parent functions there. This is the list of them on the first page of the PDF. This is the family of functions. It shows the linears and the slope on how to understand slope, what slope means. Let me go to, let's see. So yeah, let me go to that right now. So this is the video list, and I'll start with the quadratics. I'll go past the linear. So if you look at it, there's an example that's done in the video, and there's usually a now you try one to have like a self-assessment. And so you can see we have all of the transformations and then combinations of them for each of the parent functions, okay? So what you could do is you could just tell your students, if you can't do any of these, play the video until you can. I mean, it's self-taught, okay? Or you can copy and paste the links into your assignments or Blackboard or whatever it is you're using, okay? So again, I'll show you again how to find that at the end. I do want to tell you a little bit about, some people think that TI-Nspire, you can't use TI-Nspire because it has CAS in it, a computer algebra system. And over 90% of the Nspire sold are non-CAS. And I just want to show you the difference so that as a teacher, I love CAS. Having my students have it, unless I'm teaching calculus, not so crazy about it because it does so much. So the non-CAS, the numeric, which most people buy, okay, has these 3 things under algebra. Whereas the TI-Nspire CAS has all these things. I mean, it'll solve any equation algebraically, factor, expand, and so on. The calculus, which we'll ultimately talk more about at the next one, but I'll just point out there's a lot more stuff here, okay? These are things you can do on TI-Nspire CAS, like solve an equation. And look at the kind of answers you're getting, exact answers, not numerical approximations. Expand binomials, trinomials, factor expressions, even factor over the irrationals, okay? Factor over the complex, complete the square, solve a linear system, solve a linear quadratic, work with trigonometry, okay? All these things are there. And then these are more calculus things, so I'll just skip over them. But if you're interested, they'll be on the slides that you'll get from me. So again, 2 different versions. The new TI-Nspire CX2, which just came out recently, you can turn the CAS feature off. So if your students have it, you can actually turn off the feature, and it's just like a numeric one. Okay, so giving myself a hint here. All right, so making connections, factors, zeros, graph, table. So I just want to illustrate this here. And I'm going to do like Veronica did, and that is I'm going to open up a different emulator state. And I love this because I can have so many different calculators. Now I can say I want the one that deals with connections. And this will open up as like a brand new calculator, and I've already put in all these things I wanted to type in. Look how great that is. So that if I'm teaching, the students don't have to watch me type all those in. Okay, so I think this is really a helpful thing. So let me go ahead and graph this. And when I trace here, I'd like to go ahead and trace to like where the zeros are. And I want students to realize what's the relationship between the equation or the expression in factored form and the zeros. Okay, I would like them to discover that connection. And so again, I could go ahead and now turn off the equal sign on y1 and turn on y2 and graph that one. And when I press trace, you can see the equation there, and you can see that the zeros are at -2 and +3. Okay, and continue to do that. Okay, and I'll go ahead and skip that because I have on the next page, I have 4 of them that I've already done. Okay, and notice here I'm looking even with a negative leading coefficient. This one I want the students to realize that x equals 0 makes x a factor. If there's 2 factors that are used that are the same, then it's tangent. It doesn't intersect the x-axis. These are all things I want students to discover, and we have activities that you can download from the website that are free that talk them through it, or you can lead the students on your own. Okay. Logarithms to different bases. Okay. You can do this. By the way, going back to this can also be done on Nspire very similarly. Okay, so if you're using that. Logarithms to base 10, base e, and other bases. So, for example, this is my favorite right here. Log to the base 2 of 32. Log to the base 1/2 of 32. Log to the base of radical 2 of 32. Nothing special about 32, just thought I'd show that. Of course, common logs, logs to base e. Okay, notice again how I got this decimal, converted it to fraction. These are things that you can do here. And so what that means is, by the way, my tests for the last 20 some years have been no calculator, go calculator, different colors. It's because it used to, I'd say, what's the log to the base 2 of 32? And that was a good non-calculator question. I would want them, do they really understand the concept of what a logarithm is? And now I can't let that be on the 84 or on the Nspire, because the Nspire and the 84 will do that. So that's going to be on my non-calculator part of my exam. Graphs of trig functions. Here I set up a window of -2 pi to 2 pi, show every pi over 2. And here's the graph of sine, 2 cosine x, the tangent. I did not have it graph the asymptotes, though it would supply the asymptotes here. And then, of course, we can have some manipulations of the cosine and sine functions. Here I have a really complicated looking one, and so I had to change the window and the scale, and I traced this, and I think this is 1, 2, 3¼ pi right here, 13 pi over 4 I traced to, but it gives me a decimal approximation because it's not a CAS calculator. And TI-Nspire, you can see, is much nicer looking. Okay, you can have the units labeled on the axes and so on. So with that, I know that was quite a bit. I do want to talk a little bit about what's on the website and then turn this back over to Michelle and she can talk us through this. But I want to take you to the website that we created for you and explain what's there. Our email addresses are there. Lee is the person who's going to be doing the statistics with us on May 12th. So appreciate that. And so May 6th, these are Veronica's slides, and I think, yeah, there they are. Okay, so you could download them, just view them, whatever you want to do. Okay, so they're all there because I know she went really quickly. My slides are right here, so I think these are my slides. And again, I cleaned them up better than what you saw me just dragging and dropping. So anything that's there, hopefully that would help you with that. I did create a COVID vaccination data problem. So if you're interested in that, that is right here. and you can get a blog, and you can see what the looks like, okay, what the answers should look like. And I am going to be updating that in July because I'm actually doing this for a talk in Houston, camped. And so I'm going to be updating that once the video is done. This is going to be the information for next week. It's not there yet because we haven't done it. The 90-day trials are here, how to get the latest OS that Veronica talked about. TI-84 Smart View tips and tricks. This is loaded with either a PDF to explain how to do these things, or you can click on the video to see how to do things. So I highly recommend this. This is and then also a Smart View primer. You're going to be getting the TI Smart View software. This is written by the high school teacher who asked them to create Smart View, so you can get it step by step. What else is there? 84 Activity Central. I think Veronica showed you Math Inspired. This is similar, and notice it's middle grades math, Algebra 1, geometry, and so on all through here. So if you click on, let's say, Algebra 2, it breaks it down by topics. And then if you go to quadratics, it even has these individual ones. And look, our buddy families of functions is one of the links there. Math Inspired, we've already been there, but it won't hurt to go again. If you're teaching Precalculus, here are some ideas that you can use. If you're talking about exponential and logarithmic functions, there they are, okay? The transformation graphing, this is where you get that transformation graphing, okay, here. And these are all the parent functions. Click on cube root of x, it takes you there. You can play the video, the transformations are there. Or again, my main thing, to me, the main thing is for you to download that quick reference guide. I can't emphasize that enough. You just click on that, download it down here, open the file, and there you go. And if it's not going to work for you, don't use it. If it is, please share it with lots of people, because I have over 500 hours creating that website. Okay, I would love it to be used. TI's website, just for general information. Okay, you've got a link to that. Michelle Grooms is the person who's co-hosting this with us. Pri Schulte will be doing this with us next week on the calculus. Their email addresses and telephone numbers are here. I'm hoping I'm allowed to share those. And if you need tech support at all, 1-800-TI-CARES. They are outstanding. They are patient. They are nice people. So with that, I'm going to turn this back over to Michelle. Or Michelle, you want me to just go back to the PowerPoint and you talk? Is that,
yeah, that'd be great. That'd be great. Okay. Yeah, if you can do that, that would be wonderful.
All right.
Thanks.
So where do you want me to start with?
Yeah,
you can go to rewards and promotions. I just wanted to let everyone know about a couple of programs that Texas Instruments runs called TI Technology Rewards Points. And if you go to the website that we linked there in the chat, it'll take you to our website and you'll be able to access the Tech Rewards Points. We'll also be sending information out on this. But the short of it is that we want you to know there's a rewards program for colleges and universities. If you click on that portion of our website, it will take you to a form to fill out. And if you're using TI technology in your classroom, you're recommending it for your students to use, you may be eligible for free software, free technology, other little accessories and perks that you can obtain. And there's just a quick little form that you can fill out for that. It's something that we've done for many years and just kind of want to remind you of that so you don't leave anything on the table. And then we also have a syllabus promotion as well. With the syllabus promotion, it's another opportunity to reach out to your local ETC, like myself. I'm supporting Ohio, Michigan, Indiana, West Virginia, Wisconsin, and Texas, or I'm sorry, and Kentucky, not Texas, Kentucky. But there are ETCs around the US that are running the syllabus promotion. And again, if you're recommending the TI graphing technology on your syllabus and you're using that in your classroom, this is an opportunity for you to get free software for your classrooms and additional support with that too. So we'll be sending more information out to you via email on that, but just look for those opportunities to get some extra rewards along the way. And we can go to the next slide. I think the next slide is our ETC listing. These are all the ETCs here in the US, and their contact information and phone numbers listed there for you. And this is included on the PowerPoint as well on the website. You can go to the next page.
You know what, Michelle? I don't have
Yeah.
this on the website. So
you don't have the PowerPoint on the website?
no, but I can put it there.
Yeah, well,
So I will put it there. Give me a couple
Okay.
minutes after that this is done and I'll put it there.
all right, thank you. Sorry about that.
Sure. That's
Thanks.
okay. No, I just want to make sure I'm doing it right.
Yeah, thank you. And yeah, and just as a reminder, on all of your social media, follow TI, Facebook, Twitter, Instagram, YouTube. It's at TI Calculators. Encourage you to follow along, be part of the conversation there as well. And then if you have any extra questions tonight, we'll take questions if anybody has any questions they want to chat in. Daniel says thank you. Thank you, Daniel, for being here. Thank you all for being here. Tom and Veronica, thank you for hosting us tonight. All right. I don't see any additional questions in the chat. So thank you, everybody, for coming and spending your evening with us. We appreciate it.
Thank
Bye,
you.
everyone. Thank you.
Bye.